Welcome to lesson 12, where we're doing some reviewing for your second test. Let's get started. So you should have a pretty good idea of the sum and difference formulas and how to use them. Let's take and find the tan of 75. So I'm going to use this formula here, and I'm going to send to the clipboard so I can go to the next page and should be able to paste it here. There it is. All right. So there's my, and I'm probably going to do this one a couple methods just for the fun of it. Let's take a look. I know that I'm going to call this 30 plus 45. And so I'm going to say this is the tangent of 30 plus tangent of 45. All over 1 minus. Notice that if I'm using the top, I use the top, I use the top. And if I use the bottom, I use the bottom, I use the bottom. And so it's not a plus or minus formula, it's the fact that there are two formulas that we write together. So now I'm going to find the tangent at 30 degrees is root 3 over 3, plus the tangent at 45 is 1 minus root 3 over 3 times 1. And so my answer is square root of 3 plus 3 over 3 with a common denominator times the reciprocal, which would be, there's my bottom, so I'm going to reciprocal, it'll look like this. 3's go away and I'm left with 3 plus square root of 3 plus 3 all over 3 minus the square root of 3. Now, I would expect, oops, that's not what I was going after. There we go. I would expect that you would multiply by the conjugate to simplify your radical. You don't want to leave that on top. So I get 3 root 3 plus 3 plus 9 plus 3 root 3 all over 9 minus 3. And so on the top, when I simplify, I get 12 plus 6 root 3 all over 6. Simplifying one last time, I get 2 plus root 3 would be your final answer for that. Now I said that I wanted to try it a second method, and in this one we're using the half and double angle formulas. And if I take this guy and let me take a picture of that one too. And I want to put that on the clipboard. And I want to go back here and I want to paste. And I get that. So how would I use that to do the same thing I did last time? Well, I know that this is tangent of 150 over 2 equals the sine of 150 over 1 minus the cosine, or 1 plus the cosine of 150. So use the half angle formula to do the same thing. And I know that the sine of 150 is equal to a half divided by 1 plus the cosine at 150 is negative root 3 over 2. And if I simplify that, write it with a common denominator, so I'm going to say 1/2 times 2 over 1 minus root 3. And I end up with 1 over 1 minus. And of course, you would multiply by the conjugate. And hopefully you came up with the same thing as I came up the other way. Okay? What I'm getting at here is if the problem doesn't specify how to do the problem, which method, there are 2 methods for most of those. Let's talk about the double angle formulas. Sine of 2 theta is equal to 2 times the sine times the cosine. There are 3 of them for the cosine of 2 theta, and there's 1 for the tangent. There's only 1. Now, when we do the sine and cosine half angle formulas, again, they have a plus or minus in front of it. That is not for 2 answers. That is so that you pick, like if you're picking 75 degrees, we know that the sine is positive at 75 degrees because it's in the first quadrant. So look at the angle that they're asking you to find. If it's like 275.5 or something like that, we know that that's in the 4th quadrant. And the sine, all students take calculus, we know it would definitely be negative in the 4th quadrant. Okay? Good way to remember where all students take calculus. That tells you which trig ratio is positive and where it's negative. Let me pause this. Alright, so let's move on. So if I'm finding the cosine at 165 degrees, I'm going to use my half angle formula here. And the half angle formula says plus or minus the square root of 1 plus the cosine of theta all over 2. Alright, and to get 165, I'm going to use 330 divided by 2, which is 165. And so I'm going to use cosine of 330 there. And so I know that the cosine in the 2nd quadrant is negative, so my answer is going to be negative. And I'm going to go plus 1 cosine at 330 is square root of 3 over 2 all over 2. And I get 2 plus square root of 3 divided by 2 divided by 2, which is divided by 4. If I only do the top, that means divided by 2 because square root of 4 is 2. So I'm going to make sure that my radical is only for the numerator there. Now, an interesting thing happens if I do this a different way. If I have the cosine of 120 plus 45, which is 165, and use the cosine sum formula, I get cosine 120 times cosine 45 minus sine 120 sine 1 of 45. And the cosine at 120 is negative half, root 2 over 2. Sine at 120 is root 3 over 2, root 2 over 2. And so I get negative root 2 minus root 6 all over 4. Now if we compare our 2 answers, they don't look a lot alike. But if we look at them and simplify them, they would be exactly alike. So you can kind of tell by your answer which method is And they're both correct, so don't worry about it. One thing that I have to remind you is you're supposed to be doing these things without calculators. So when I see decimal answers for stuff, that makes me think that you're using your calculator. So when we're solving trig equations, my example here is 2 sine squared of 2x is equal to -1. If I divide, I get -1/2. And so I'm looking for the angles on my unit circle, because the sine is the y. Oh, if I square root. Oh, this isn't going to work at all. Let's make that a +1. So then I get the square root of 1/2, which is the sine of 2x is equal to the square root of 1 is 1, and the square root of 2. Rationalize, I get the square root of 2 over 2. And so I get plus or minus in front of that. So my square root of 2 over 2 is there. So I know that my value is at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 are all answers to this. But we have to be careful here because we're equal to 2x instead of x. So the angles that actually work are pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. And those all happen before pi. And we know most of the time when we're doing these kind of problems, our interval is from 0 to 2 pi. So how do we find the second set? Well, we know because we graphed this kind of thing before. This number in front of here takes your period, which is 2 pi, and we have to divide it by 2, so our period becomes pi. So if I add pi to each of these, I'm at the same place just in the second period of it. So those would be your complete set of answers for a 2 theta case. Now our inverse trig stuff tells us that we have limitations, and we know that our sine can only be in the first and fourth quadrants, so that's why we have the negative pi over 2 to pi over 2. The cosine is from 0 to pi, first and second, so this is first and fourth, not sixth. Good grief, Mr. Otto, don't you know your Roman numerals? So first and fourth, this is cosine is first and second, and the tangent is the first and fourth. But there is a little bit of difference here. Notice that there's no equals to, and that's because at pi over 2 and negative pi over 2 we have asymptotes, so they're undefined at those edge places. So why is this not true? Well, we know this is not true because there's an inverse cosine in it. So if I find the cosine, if I work my way out, the cosine at 3 pi over 2, cosine is the x, I get a 0 value, and the angle whose cosine is equal to 0 would have to be pi over 2. Because we know that this is not defined on the interval from 0 to pi where the inverse cosine is. But at pi over 2, I get the same answer as I do at 3 pi over 2. So because of this, we have to only pick answers that are where it is defined. So the composition of inverses, we need to be able to find the inverse of a function and then prove that they are inverses. So I'm going to take this one, and I'm going to find the inverse, and then I'm going to show that they are inverses. So I'm going to take this as a y and replace y's with x's and x's with y's. And then solve for y. And so I get my y is x plus 2 over 3. Now, it could be rewritten as 1/3 x plus 2/3. And so to prove it, I need to say f of